Hello everyone, so I'm back again to explain one more problem to you all. Let's look for the question number 18. Most of you asked for this question. Let's see what is there in this question. Let me read it for you. In the adjoining figure, ABCD is a square with side of length 6 unit. Points P and Q are the midpoint of the sides BC and CD respectively. So we can see here we have a square and the side of this square is given as 6 and it is given that P and Q are the midpoints of the side DC and BC. So now I am labeling this figure. I have already labeled it. Look here. This is 6, this is 6, but because P is the midpoint, so I can say these both are 3, 3 each. Here Q is the midpoint, so we can say these both are 3, 3 each. If a point is selected, if a point is selected from this whole square, what is the probability that the point will be chosen from the interior of a triangle? We are to give the probability. हमें probability देनी है कि वो जो point है वो select किया है हमने इस triangle में से. Say, you people have seen same kind of question in NCERT book also. There in that book they have given one rectangle and there was one circle in between that rectangle, and they said if a die is thrown in that rectangle, what is the probability that die will go inside the circle? Same way here we have chosen one point. The concept is exactly same. We will go with the same kind of concept. What we will do, beta, since we are to find the probability that the point is chosen inside the triangle, and we know that point is chosen from this square, so the probability will be given by area of triangle upon area of square. Total number of, look, the formula which we have seen for the probability is favorable outcome upon total number of outcome. Now here if you look for the situation, we are to choose a point from the square. So possible outcome is this whole square. A point can come from anywhere from this square. So the area of this square give us the possible space from which we can choose a point. And favorable space is this triangle. So area of this triangle is the favorable area. So the probability will be favorable area upon total area. Here instead of saying favorable outcome upon total outcome, we will say favorable area upon total area. So we need to find the area of this triangle. Let's see whether we can find the area of this triangle or not. Here we don't have side of this triangle, and we all know that to find the area of this triangle we need its side. Let's see whether we can find side of this triangle or not. If you look for this triangle ABP, we can see that this is 90 degree because it is given that ABCD is a square. So here we can use a Pythagoras theorem, and for using Pythagoras theorem, what we do, 6 square plus 3 square will become AP square. So in this way 36 plus 9 is equal to AP square, and this will give you 45 is equal to AP square. So we got AP as 3 root 5. We got this side as 3 root 5. Sorry, miswritten. 3 root 5. Yes, similarly this side will be 3 root 5. Now when we come to side PQ, here these two sides are 3, 3 each. So what we do, we find by Pythagoras theorem, we find this side, and 9 square plus 9 square 18 under root 18. Under root 18 means 9. 3 root 2. This is 3 root 2. So we can find the area of this triangle by Heron's formula. This is one of the way. But look, this is a very lengthy approach. There is one more way to find the area of this triangle. Let me tell you that way also. Look, area of square is, let me write it on another sheet. Have a look here. Area of square will be 6 into 6, that is 36 square unit. Now to find the area of triangle, to find the area of this triangle, what I will do, I will find area of these three triangles and then I will subtract area of these three triangles from the area of square. Now look, area of ADQ can be given as half AD into DQ. Look for triangle ADQ. ADQ, we know this is 90 degree. If this is 90 degree, we can take this as a base and this as a height, or this as a base as this as a height. So in this way, the area can easily be calculated as 1 upon 2, 6 into 3. So it is 9 square unit. Similarly, we got the area of this as 9 square unit. Similarly, area of this triangle will also be 9 square units. So let's write it. Area of ABP is again 9 square unit, and the third triangle is triangle QCP. Let's see what will be area of QCP. Area of QCP will be half base 3 and height 3. So 9 upon 2, that will be 4.5. So now area of required triangle will be given by area of square minus, so area of required triangle. Area of required triangle is equal to area of square minus 9 plus 9 plus 4.5. So that will be 36 minus 1822.5. So that will be, so what it will be, 23 minus, we subtracted from this 13, 12.5. 12.5 square unit. Sorry, it will be 13.5, not 12.5. 13.5 square unit. So now required probability is area of triangle, that is 13.5, and area of upon area of square, that is 36. So that will be the required probability. Fine, I hope you all understood it. Still, if you have any problem, write me on a comment box, and or whenever you come back to me, you can ask me in classroom also. Okay, goodbye, have a nice day.